to the second half of 2.5. So 2.5 is when we started really starting to get into our proofs. Today we're going to be on page 15 to begin. Now the first proof on here is actually a type of proof we've already done. I started off with one that's kind of more about that 2.5 part 1 because of the fact that the proof structure and the things you look for in a proof are going to be the things that help us get through proofs in chapter 2, in chapter 3, in chapter 5. I don't think we do proofs in chapter 7. So it's going to be a structure that we continue to use. So when it comes to a proof, first thing I have to do is write down 2 columns. What are technically the titles that go on the top of those columns? Close. Statements and reasons. Do you have to write out statements and reasons? Not technically. What am I okay with you shortening them down to? Just S and R. So that is going to be a common thing throughout proofs as well, as I'm going to talk about what it is okay to shorten things down to. You're always allowed to write out the full thing, but it's nice not to have to. Now, when it comes to our proofs, you should always know how they start, because every single proof, regardless of the proof, starts with what? The given information. Is given a statement or is given a reason? It's a reason we know something is because it was given to us. Grab a calculator if you don't have one. Make sure you are numbering your steps in your proof as well on both the statement side and the reason side. My given information here is SR equals 544 plus 6x. RQ equals 73. SQ equals 8x plus 795. Now, I can write those all as one line separated by commas. I prefer to separate them down. I feel like it makes it easier to kind of see. When looking at our proofs, one of the things I've told you is there's 5 key things that you look for to figure out where to go next in a proof if you don't know. Now, many of you probably know exactly where to go next on these ones because we've practiced these ones. But those 5 things are going to get important as we get more and more complicated with our proofs. So I'm going to go through those 5 things. When going through a proof, the first thing you should look for to figure out what to do next, we wrote it on the top of the previous page. Words. Segment addition postulate is a thing we do. Yes, it's the thing we do here. But first thing we look for is words. Inside the proof, do I have any words? No, so I move on. Second thing we look for. Go ahead and look back. Like I said, it's on the previous page. Symbols, such as congruent symbols, perpendicular symbols, and parallel symbols. Have I got any of those? No. Third thing. Algebra's 4. We'll come back to that one. Substitution or transitive popping up. Substitution and transitive, how you can tell you see them, is you see the same thing popping up in 2 places in the proof. Specifically, it has to be in things with equal signs. And one of them has to be that thing equal to something else. Now that being said, when I'm talking about the things I'm talking about, like the names and stuff, are any of those repeating? No. So we move on. Then we look for, Jackson, what did you say was the next one of the things we look for? Algebra. And then the last thing we look for is the picture. On the orange sheet. It doesn't say anything about picture. What word does it use instead? Things you get from a diagram. So, by the way, when it comes to this orange sheet, and I maybe should have said this yesterday, but I've noticed y'all are doing this anyway. You shouldn't write anything on this orange sheet that I don't write on it. Okay, things we get from a diagram. There's two different types of diagrams that we see. Does that look like either of them? Yeah, it kind of looks like the first one. So, that's where we go next. If I'm going with that idea, I'm going with using this idea. Peyton, what goes here? What do you mean by that? Actually, no, I can't jump directly to that first. I need to jump to the lettery version of it first. That's what this thing tells me. That's the key thing about proofs, is you can only write down exactly kind of what they say, just modified for the problem. And this one says you have to write things in letters. Nate, what's the lettery version, but for this line?
SR equals RQ. No, SR plus RQ equals SQ.
There we go. Aaliyah, what's our reasoning for that? The segment addition postulate, which we can shorten down to seg add post. No, you don't have to have the periods on them, but I do. Then, once we have that, then we can go back through our 5 things. We didn't all of a sudden add words. We still don't have symbols. But now I see some things showing up twice. Do you see SR on here twice? Both in things that have equal signs, one specifically equal to everything else. Same thing with RQ, same thing with SQ. Then we can move to what Peyton was telling us to do. SR instead of it was the 544 plus 6x. RQ instead of it is the 73. SQ instead of it is the 8x plus 795. I literally was about to call on you. I don't doubt that you do. And what we did there was substitution. We replaced something with what it was equal to. Okay. From here, I can go back to my 5 things. I don't have words, I don't have symbols, I don't have substitution or transitive anymore, but step 4 says I'm doing algebra, which is what I'm doing, which many of you probably thought that anyway. The 5 things is if you don't know where to go next, you check the 5 things. And we're going to do some algebra. Diego, what kind of algebra would you tell me to do next? What would be my next step, in other words? Add what?
73 and 544.
Okay, we're going to add these 2 together, but the actual reason's not called add. 544 plus 73, 600 and something. 617, thank you. Positive 617 equals 8x plus 795. Now the reason's not called add. Add implies I did something to both sides of the equal sign. It is combined like terms, but that's not the reason either. Oh, I heard someone say it. It's a simplified step. Things like using PEMDAS and combining like terms are simplified. Yes?
When you subtract things, do you have to subtract it in that order where you have the x on the right side?
You do not. If you'd prefer to put it on the left side right away, because you know that it's gonna want to be on the left side, you can. So, based on that, generally speaking at this point, we'd put our x's together. Most commonly, y'all have been taught to move the smaller of the 2 x's, but you don't have to. If you know x's have to end up on the left side, you can move x's to the left side and subtract the 8x instead. Are you going to get negative numbers? Yes.
And then you don't have to do the last step where you have to switch over.
But it skips the symmetric step.
Because I normally do it the other way, but I don't know if you have to do it differently. That's
Mm-hmm. You can do it either way. The key thing is, do you want to skip symmetric or not? This helps you skip it. Gives you fewer steps. Now, that was subtraction. SUBTR. Now, if I'm going to go this way, Jada, what would you tell me to do next?
Subtract 617.
Love it. Okay. Remember, the actual minus 617 that I'm writing here isn't the actual step. It's just math to help me see what's happening. Negative 2x equals 178. And that was subtract again. And I've only got one more step left on this one. By moving the x's to the left side, I made this a 7-step proof instead of an 8-step proof. Our last step proof would be to do what, Amariana? Divide by the negative 2. If I divide by negative 2, I get a negative 89 on the right side. Is that what I wanted?
Yep.
Yes. We did our math right. Our proof matches our final statement. In a proof, if you get stuck knowing nothing else, you should know given, this, and the very last step. If you know nothing else. Okay. Let's change up our proofs though. It's still a proof, which means I'm still going to do my 2 columns. I'm still going to label this one statements or S. I'm still going to call this one reasons. I am still going to say that every single proof, regardless of the proof, starts with the givens. And I was given measure of angle NQR equals 14x. Now, one thing that's interesting sometimes about the angle proofs, notice the parentheses with the degree symbol. The parentheses are only there to hold the degree symbol. If they're only there to hold the degree symbol, honestly, in the proof, I don't tend to write them. If they're there to hold anything else, I have to put it. But if it's just the degree symbol, I don't worry about it. So measure of angle PQN is equal to 18x plus 5. The parentheses were holding the degree. I don't care about it. Measure of angle PQR is equal to 165. And I also don't write the degree symbol. Not in the middle of the proof. Can I? Yes. Do I have to? No. I go back to my 5 things because this proof's a little bit different. And I can't use segment addition postulate. It's not segments. First thing I look for? Words. Do I have any words? No. Second thing I look for? Symbols. Do I have any symbols?
Yes.
Technically, yes. I have actually 3 different symbols popping up here. Equal sign is technically a symbol. Plus sign, technically a symbol. Angle symbol. Symbol. But here's the thing. That's not the symbols I'm looking for. I'm looking for congruence, parallels, and perpendiculars. So there are symbols, but are there the important symbols? No. So I move on. Substitution and transitive property. I'm looking for 2 things popping up in the proof, or something popping up in the proof twice. Are any of those the same angle? No, so I don't have anything popping up twice. 4th thing's algebra. Can I start solving anything with those? Not with as they're written as is. 5th thing I look at is the picture. So I go to my postulate sheet. My postulate sheet has two different versions of the picture. It's got the segment addition postulate, which we already established. That is not segments. Those are not segments. And then we've got the angle addition postulate. Angle addition postulate, which we can shorten down with the angle symbol, or you can write angle, add post. Angle addition postulate says that if I have something like this, if I have two, they're called adjacent angles, angles right next to one another, I can say the measure of angle CDI, that's one of the little angles, plus the measure of the other little angle. The other little angle, I'm going to call IDE, is equal to the measure of the big angle. Much like when working with the segment addition postulate, if you're going to do the angle addition postulate, you're going to have a situation. Okay, but let's do math right now. Thank you. Much like when doing segment addition postulate, angle addition postulate, you have to do the letter E version before you can do the algebra E version. So in this proof, my next step, using that diagram, since I have that picture, I'm going to do the angle addition postulate. And the actual postulate itself is going to look like this letter E version. So I need a small angle and a small angle adding up to the big angle. What's the name of the top small angle? PQN. Now, notice how they have the little measure of angle symbols in the formula. I need to make sure I have that too. Measure of angle PQN plus. What's the bottom little angle? NQR, measure of angle NQR equals big angle, measure of angle PQR. I can go back to my 5 things if I want. You're going to oftentimes notice that things that weren't there aren't going to suddenly pop up when it comes to words and symbols most of the time. Most of the time. Words rarely pop up if they weren't there at the beginning. There's no words. Symbols, I don't see a congruent, a perpendicular, or a parallel. Do I see 2 things showing up, or something showing up in 2 places? CPQN, NQR, PQR, replacing something with what it's equal to, substitution. Substitution happens a lot. Measure of angle PQN was the 18x plus 5. Make sure you're putting the correct one in the right spot. Measure of angle NQR was the 14x, and the measure of angle PQR was the 165. Don't forget to put the plus sign that was here and the equal sign that was there. At this point, yeah, I could go back to my 5 things, but I have zeroed out in my mind. Most of you are going to be like, I know what to do now. It's algebra. So that's what we're going to do. When it comes to the algebra, Charlie, what would you tell me to do right now? Add the 18x and the 14x. 18 plus 14, 32. Maybe. So I get 32x. I still have a plus 5. I still have it equal to 165. Brody, what's that step actually called, though?
Simplify.
You got it. Jasmine, what would you tell me to do next? Subtract what? 5. So we're doing subtract. Subtract the 5. 32x equals 160. Haley, back in. How would you tell me to finish it off? 5. Divide by 32. The reason is divide. Divide by 32, and I get x is equal to 160 divided by 32? 5. Now when I solve for x, I double check. Was that what I was trying to prove in the first place?
Yeah.
Is it in the correct order? What if it was 5 equals x? You wouldn't be done yet. You'd have to flip it using what property? Symmetric. S-Y-M-M. Okay. Next two, very similar. Slight twist. Every single proof, regardless of the proof, starts with given. Measure angle BCD equals 170. Measure angle LCD equals x plus 151. Measure angle BCL equals x plus 21. At this point, some of y'all might be starting to wonder why I keep bringing up the 5 things, because you're like, I know what to do next, Benson. And I'm glad you know what to do next. If you don't have to go back to the 5 things on every single proof, that means you're learning something. It's a good thing. I will tend to go back to the 5 things because I know where we're going. I know that as we get into 2.6, we're going to start getting to more complicated proofs that tell you more complicated things to do. And I also know that soon those proofs are going to be mixed together. So, yes, I will typically go back through the 5 things, but I go pretty quickly through them. Do we have words? No. Do we have the important symbols? I see people shaking their heads. No. Do we have substitution or transitive right now? No. Algebra? No. Picture. I have a picture. It's angles, so it looks kind of-ish like this one. It's not perfectly like this one, but the key thing is 2 angles right next to one another. Ava. What would the lettery version of the equation look like for this picture? Mm-hmm.
Measurement of BCL plus measurement
Doing wonderful. BCL was the first one. So that's the little one. We need the other little one. The big one. And the big one's name is BCD. Some of you may have gone and said measure of angle DCL plus measure of angle LCB equals measure of angle DCB. And while that's not wrong, if you said this angle and this angle adds up to the big one, there's nothing wrong with that. The only thing I would caution you is be careful on how you're naming them. This top one, can I call it angle DCL? Absolutely. Is there an angle DCL in here? Not exactly. Haley, heart. What was my reasoning behind that? Angle addition postulate. Angle add post. Okay. Jackson, what would you tell me to do next? I can't simplify anything yet. There's nothing to simplify. I think you're a step ahead of us.
Property thing.
Substitution. S-U-B. At least get to the S. So we're going to do substitution. Cam, when I substitute in, what's it going to look like?
170 or x plus 21
Yeah, let's start with that. X plus 21, because that's the measure of BCL, plus,
plus x plus 151.
you got it, equal to, you got it. Kylie, what comes next? We would simplify. Zion. What does the simplified version of this look like? 2x and whatever 21 plus 151 is, which is 172, equals 170. This is algebra. You subtract 172. 2x equals negative 2. That was subtraction. We divide. Divide by 2, x equals negative 1.
What do substitution? And then simplify.
Do you notice that's not what it asked us to prove? Doesn't mean we're wrong, means we're not done. It would mean we're wrong if it asked me to prove something that said x equals 150, because clearly x is not 150. But it didn't ask about x, it asked about the measure of angle LCD. Remember, just like back in chapter 1 when you solved and plugged back in, you sometimes in a proof have to solve and then plug back in. So when I plug back in, I must write out measure of angle LCD equal to, it was x, I'm going to replace that with negative 1 plus 151. I am replacing x with what it is equal to. Plugging back in is substitution. You substitute back in. Yes, you need the measure of the angle name in that substitution. And then you're doing some PEMDAS to get it all together, which is simplify. So sometimes you solve for x and then take it a step further within the proof. Plugging x back in is substitution. Getting it down to a single number is simplify. At this time, I'm going to have you try out the last one on your own. I'm going to finish the problem up here on my own so that it goes into the video for those that are not here. And then I'll be coming around and checking on people.